All right, this is a last lesson for our trigonometry unit where we're working with the triangles. Our next unit's going to work with trig functions, but we're not there yet, so don't worry about that yet. I want to summarize all the tools that we have for helping us to solve problems using trigonometry. Regardless of what type of triangle you have, you know that the angles have to add up to 180 degrees, and that's useful regardless of whether it's right-angled or not. If you have a right angle triangle, then you can use that Pythagorean theorem where your hypotenuse squared is equal to the sum of the lengths of the squares of the lengths of the other two sides. So that is just that c squared equals a squared plus b squared, where of course the c is your hypotenuse. It has to be the longest side here, hypotenuse here. The other thing that we went over is the SOHCAHTOA, how to use that to solve for side lengths or angles. But again, that only works when you have that right angle triangle. It doesn't work for non-right angle triangles or what we call oblique triangles. If you need to make yourself some more notes about SOHCAHTOA here, you certainly could. All right, make this sort of a summary of what you should know at this point. The new things for people who did not do 2D last year are the sine law and the cosine law. The sine law was the one that said A divided by the sine of angle A has to equal B divided by the sine of angle B. And remember, these letters could be any letters at all, but the key is that you have your side length divided by the sine of the angle across from it. So you can write it that way, or you could also flip them both over, flip everything over, and put your angles on the top, the sine of the angles on the top. So sine of angle A over side length A will equal the sine of angle B over side length B equals the sine of angle C over side length C. Whatever I'm solving for, I usually put on top. So again, you might want to add a little note about that. The sine law only works if you have a complete ratio. So you have to have a side length and an angle across from it, and then one other piece of information. You might combine that with the angles add to 180 degrees to be able to get that other piece of information, but ultimately, you have to have a complete ratio, a side length and an angle across from it. So again, add that into your notes here if you need to. Now our cosine law, that was the one where we had c squared equals a squared plus b squared. Starts out like Pythagorean theorem, but then because it's not right angled, we have to adjust, and we take away 2 times a times b times the cosine of angle c. So remember, whatever we've got as a side length here, we're taking the cosine of the angle on the ends, and then the middle matches up. Your A and B goes here, and your A and B goes here. So we also were able to rearrange that to be able to solve for an unknown angle when we know all three sides. So there's two cases when we use that sine law. We use it when we have two sides and the contained angle of a triangle. So we know this, and we know this, and we know this. Or when we know all three sides and no angles at all. So if we have our x, y, z, or ABC, could have used that. That would make sense because I've got ABC there. Cosine law is only used in those two cases. All right, so I have one problem here that I'm going to work through with you. The hard part for this, the key idea for this is you've got to decide what tool to use. So that's where it's important to know which tool works with what kinds of triangles. We're going to determine the height of the tower in the triangle shown. The tower is A to D, just so you know that. A to D is where the tower is, and we need its height, its length. Now, if I look at side AD, it's a side length in triangle ADC. It's also a side in triangle ADB. However, in those two right angle triangles, I only know angles. I don't have any side lengths, so that's not going to be helpful yet. If I look at the big triangle, the ABC triangle, I have two angles and one side, and when I have two angles, by default, I can figure out that third angle up at the top. So I'm going to start this by saying what triangle I'm working with. So I'm going to say in triangle ABC. So everybody knows who reads my solution what triangle I'm using here. Angle A is going to equal, and I didn't have to put that angle symbol in there, I just do that sometimes when I say the word, my hand just wants to write that. It's going to equal 180, subtract the two smaller angles. Now I have to get my spectacles on so I can actually see what I wrote there. Oh yeah, 75 degrees. 75 degrees, and we're going to subtract 53 degrees there. All right, so angle A, capital A, is going to equal, boo, 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 52 degrees. Oh, it's almost isosceles. I really didn't mean to make it that way. Anyway, that's okay. So this is 52 degrees at the top. Now that I know that 52 degrees is here, I have a side length and an angle across from it. So I am thinking sine law is what I could use. So I could use sine law and solve for side B. So let's do that. So I'm still working with triangle ABC. I'm going to use my sine law. I want to solve for side length B, so I'm going to put it on the top. And that's divided by the sine of the angle across from it. And then I'm going to use the A over the sine of angle A. So fill in what I know here. Sine of angle B would be the sine of 75 degrees. That's going to equal little a, which is 48, divided by the sine of 52 degrees. And then to get b by itself, it's being divided by the sine of 75, so I want to undo that by multiplying both sides by the sine of 75 degrees. And then I get my trusty calculator here, and I'm going to go 48 divided by sine of 52 degrees. That gives me about 60.9, and I'm going to times that by the sine of 75 degrees, and I get 58.8, or almost 59 meters there. So 58.8 is going to be my B value, 58.8 meters. Now, I know in triangle ADC, I know the length of the hypotenuse. So if I look at my triangle ADC, A to D to C, I know the length of the hypotenuse is about 58.8 meters, and I know this angle here is angle C is 53 degrees. That makes side AD the opposite to it, and we have hypotenuse. So I'm thinking sine is going to work with a right angle triangle. So now I'm going to say in triangle ADC, I am going to use the sine of 53 degrees, and that's going to equal my opposite, which is side AD, or I could use the little letter C because I've told us what triangle I'm working with, over the 58.8. Now I still have all those digits on my calculator. I'm going to take that answer I have, that approximately 58.8. I'm going to use all the digits on my calculator that I have still there, and I'm going to multiply that by the sine of 53 degrees. And I get about 46.98, which is going to round to 47.0. So my side AD is 47.0 when I round that carefully. So therefore the height of the tower is about 47 meters. And of course, because it's a word problem, I put a therefore statement with it.